I'm John Barsotti, founder and president of Heron Innovators, the home of the Suspended Air Flotation System, or SAF. Welcome to the IPPE Tech Talk, a better way to reclaim and reuse wastewater. In the 21st century, wastewater is now considered a resource, whereas in the 20th century, it was a waste product. Even though fresh water is still an inexpensive product, and reclaiming wastewater is more costly, the resource is diminishing as demands increase. The U.S. has an estimated 4.3% of the world's population and 7% of the global renewable freshwater resources. Yet, Americans consume nearly twice the global average. The U.S. Government Accountability Office reports 40 out of 50 states expect water shortages within the next 10 years. That regardless of drought conditions. A positive trend is that Americans have reduced their demand for fresh water by 9% over the past 20 years. However, conservation will only get us so far. Water reclamation and other sustainable practices are our only way forward. The price of water, although is not in most of the country, isn't prohibitive at this point. Fresh water I'm talking about. When compared to what it costs to reclaim the water, there's this growing awareness that the resource is depleting. A good example of that is the Ogallala Basin, or the aquifer that services fresh water, pretty much from South Dakota down to Texas. A little bit of internet time will show you that the thought is that water source will be 70% depleted in 50 years, and at that point it would take 6,000 years to regenerate that resource given the current recharge mechanisms. The suspended air flotation system is sought after because it is a uniquely sustainable solution to today's water reclamation challenges in industry. On the industrial side, oftentimes it's agricultural water or food, going to a food processing plant, coming from a food processing plant. The pathogens aren't really the concern to a point. They're not the concern. And there are operations that can accept lesser forms of reclamation. So our technology works really well for that because we can take a pretty good cut of the suspended solids, something like 90 to 99% removal. And you have, and most of our applications are greater than 95% removal. And at that point, you've got essentially roughly filtered water, if you will, that you can return for, if you're a packing house of, pin washing operations, those non-sensitive operations. We have an SAF generator, and it looks something like this. This is a smaller one, of course, but our SAF generator generates a population of bubbles that are 7 to 25 microns in diameter. Our white water, because we don't have to deal with the physics of dissolving air and water, is like 40% or 50% air. We don't need a lot of pressure in the system for anything but trying to agitate the solution and delivering the product to the process, and everything we move has got 20 times the air you might find in a DAF white water, what we'll call this white water. So all in all, we're moving a lot less material at a lot lower pressure, and it's a lot less horsepower. It's one of the big advantages, especially when you in a world where we're talking about sustainability and those kinds of things, carbon footprint, whatever you have. The froth is a surfactant. It has surface tension advantages and electrostatic attraction advantages. So we act a little bit like a coagulant. Because of the surface advantages, we overcome the surface tension limitations of the particle that a DAF bubble is challenged with all the time. And with that, we get a lot more air on the particles. We get very fast rise rates. And that all translates to, of course, the lower horsepower, the smaller footprint, lower capital costs, lower operating costs, and chemical savings. One of the questions we'll always get asked is the frothing agent cost. And well, the reality is we feed it at very low concentrations to the point where it's oftentimes, if you were to compare it to the cost of operating a DAF, that cost is more than offset by the costs of the horsepower you turned off in comparable DAF. The other thing you might notice is how the particles seem to puff up. That's that coagulation feature I was talking about. That saves you a lot of chemistry. In the industrial side, we're always looking at like 30% plus chemical savings, 30 to 50%. And in the municipal side, it's oftentimes more than that. It's like 50, 60, 70% chemical savings. So on this slide here is just to kind of show you how things lay out, right? This is a customer of ours, a greenfield site, but there's two CF 1000 clear floaters. Those at 140 square feet. They can run about 2,800 gallons a minute of water. And just real quickly, that's 20 gallons a minute per square foot loading. They had very high solids coming into this tank, and they were running that system at 2,400 gallons a minute at 35 pounds per hour per square foot, which is the other loading parameters, solids flux. And we have no trouble going to 30. We know in most applications we can do into the high 40s in pounds per hour per square foot, and that was the case here. They were at 35 pounds per hour per square foot. The customer actually called me and said, we would run harder, but the pumps just can't put out anymore. But no doubt, the water quality was excellent as it was at much lower run rates, and the water was clean. So on the right side, that's our secret formula there. That's our sauce, and that's the SAF generator, and that generates the micro froth. One of the things that's pretty nice about this is everything upstream of a diaphragm valve is controlled automatically. So adding more or less air is just as easy as turning on and off a water faucet. And then down here on the left side is a flock tube, but most of you see that. We have them as well, and those flock tubes, for us, for the most part, if you're adding polymer, you're adding it very late in that process, probably don't need it in most applications. I mean, there are some. And then otherwise, for the most part, those flock tubes are about pH control, getting the residence time for pH control and for coagulation. So you can take the treatment train however you like. Often in the most expansive treatment train we see, we'll do some sort of pH control coming in. You'll have to screen the water, go to an EQ tank, go to some sort of primary clarification, the SAF, right? Remove the solids, go into a biological process, remove the dissolved organics, and then recover or just remove the biomass from the biological process. And then, there could be a polishing filter depending on how clean you need it. Could be RO depending if you need drinking water level clarification. Some sort of disinfection oftentimes in food processing as they're worried about pathogens one way or another making their way back. And so you got this treatment train you can pick from, and oftentimes it works serially, right? So you'll have some screening and EQ tank in the SAF to do a lot of the pin washing operations, external washdowns, maybe even some external irrigation, depending on how much land you have to apply it to. That water may need to be cleaner to enter into a plant, especially in food processing, right? You may need to achieve a chlorine residual or disinfection, and you might find that there's too many dissolved solids in the water to effectively get your residual. So you need to go to a biological process, reduce the dissolved organics. Really common in industrial settings today are the moving bed biological reactors, MBBRs. Biological processes generate something that needs a wastewater needs to be clarified of the biomass, and again the SAF fits that role as well. Then downstream of that, you have the choice of do you need to polish with a filter, or do you need to polish with a filter in front of maybe an RO membrane where you're going to actually return the water as drinking water, as potable water to the process somehow, or if we're going to go to drinking water, we're going to go further treatment for the intent of trying to achieve something that could actually be in the product, right? Especially in food processing, that can be a concern. Here at Heron, we're actually have a fair amount of experience in reclaiming water in industrial settings, as most of our business is in the industrial space. So if we can provide any information or any help, our contact information is on the screen. Thank you for your time, and we look forward to hearing from you.